Given a positive number, we have to find the complement of a number. Example, the given number is 5, which is represented as 101, and its complement is 0, 1, 0. So we have to flip all the bits. If we flip 1 to 0 and 0 to 1, this 1 to 0, we get its complement. And this is nothing but the decimal number 2. Similarly, the complement of 1 is we just flip this bit, we get 0. And also they are given that the range is a 32-bit signed integer. One way to solve this problem is to go to each of the bit portion and change its bits. For example, the given input is 101. We go to each of the bit portion and reverse its bit. So first we go to the bit 0 and we reverse its bit from 1 to 0, and then to the second bit we reverse its bit from 0 to 1, and then this will become 0. This is nothing but decimal number 2. We return this value as the output. For reversing the bit operation, we use the XOR operation, because if we look at the truth table of the XOR operation, if we XOR 0 with 0, we get 0. If we XOR 0 with 1, the output is 1, and we XOR 1 with 0, the output is 1, and if we XOR 1 with 1, the output is 0. So if we assume this and this is the X value, so if we XOR this value with 1, so whatever the value it is, it will be flipped to 1. So similarly, if we are XORing this X value with 1, the value will be reversed to 0. So that is the reason we use XOR operation for flipping. For changing the bit mask in each position, we use a bit mask. So this is the solution. The given input is num. We make a copy of the number because we'll be modifying the number itself, and then we initialize the bit mask to 1. We start iterating while the copy of the number is not null. This is the first we reverse the bit in the bit position. The bit mask is initially set to 1, and then we left shift the bit mask so that the bit mask will now go to the second position, and the num copy will right shift to the 1. So we'll iterate the num copy towards the right side until we cover all the values. We'll go through this with an example. The input they have given us, input is n, num is 5, that is nothing but 101, and we make a copy which is also 101, and then we iterate this. In the first iteration, what will happen is, and the bit mask is also set to 1. In the second iteration, we have the num value as 101, and we do a bit mask operation. We do a XOR operation on the bit mask. The bit mask is 0, 1, 0, and only the value where we have 1 will be flipped. So this value 0 will be flipped to 1, and remaining will remain as it is. And then the bit mask will be updated. So bit mask is, current bit mask is 0, 1, 0. It will be left shifted by 1. So if it is left shifted by 1, so the new bit mask will become 1, 0, 0. In the third iteration, we have the num value as 1, 1, 1, and we do a bit mask. So the new bit mask is 1, 0, 1, 0, 0, 1, 0, 0, and the output is 0, 1, 1. So only this, wherever 1 is there, that value will be flipped. So this is the output. And also, if we track the num copy here, it is 1. Again, we'll do a right shift in the second iteration. The num copy will become 1 here, and here the num copy will become 0 if we do a right shift operation, and then it will break out of this while loop and will return this num, whatever the result we have here. This is the second method. In the previous method, we used to flip each and every bit. In this method, instead of flipping each bit one by one, we can create a bit mask of all the bits and then do an XOR operation to flip all the bits at once. Given input is num is 5, 105, 101. This is 5, and the bit mask is set to initial value of the mask is 1, and this mask value is less than 5. So we get into the while loop. In the first iteration of the while loop, the mask is nothing but mask is equal to mask is left shifted by 1, and then we do a XOR operation with 1. The mask value is 1, and we left shift by 1, and then OR it with 1. So this is nothing but 1 0 after left shifting by 1, and then once we OR it with 1, the output is 1 1. And this value, mask value, is still less than the num value, so again it will go into the while loop. In the second iteration, the mask value is nothing but 1 1 left shifted by 1 and then ORed with 1. So once we left shift by 1, so this will be 1 1 0, and then ORing with 1, the output will be 1 1 1, and this value is 7, and this value is greater than the num value, so we will break from this while loop, and the mask value is 1 1 1, and then in this line we XOR the original num value with the mask value what we generated. So the mask value is 1 1 1, the num value is 1 0 1. If we XOR with 1 1 1, the resulting XOR operation will be this is 0, this is 1, and this will be converted to 0. So we'll return this value.